All right. Well, it looks like we're already starting to get some good critical mass here. So I'll get started on my spiel, and then hopefully folks will be fully in by the time the interesting part comes. Um, so yeah, good evening everyone, and welcome to the ACS San Francisco Bay Chapter's final 2024 speaker event. I'm Wade Cobb. I sit on the board for the Bay Area chapter of the American Cetacean Society. For anyone new to to ACS, our national organization is the oldest nonprofit dedicated to the protection of whales, dolphins, porpoises, and their habitats. We do this through education, community engagement, and awarding grants for cetacean research. We appreciate all of your donations in support of our mission. It's really easy to donate on our website if you haven't already done so when you registered. We're also very excited to announce our new research grant. The application for that is now open. All the information is on our website. Helping fund research toward cetacean knowledge and conservation is a critical part of our mission. So please spread the word and reach out with any questions if you have any. Um, so that brings us to tonight's presentation. Please put any Q&A that you have in the function in like the Q&A function below, not the chat. And we can get to that at the end of the presentation. So tonight we are putting a spotlight on a cetacean that we don't often hear too much about. We're thrilled to have scientist and expert Jessica Crance to speak to the plight of the North Pacific right whale, right in our backyard. So Jess is a research biologist at the NOAA Alaska Fisheries Science Center's Marine Mammal Lab. She joined the lab Cetacean Assessment and Ecology program back in 2009 after completing her master's at the University of San Diego on orca whale vocal development. Her research focuses on marine mammal passive acoustics with an emphasis on population monitoring, spatio-temporal distribution, vocal behavior, and call characteristics of Arctic and subarctic marine mammals. She has studied marine mammals across the North Pacific and Alaskan Arctic using a variety of acoustic platforms with a focus on finding and studying the critically endangered North Pacific right whale. So thanks for being here, Jessica, and for sharing your knowledge with us. And with that, I'll hand it over to you.
Great. Thank you so much. Really appreciate it. I'm going to go ahead and share my screen. All right. So hopefully everyone can see that. And I do want to start by saying we are now in the process of starting to get a pretty substantial windstorm here. I'm really hoping the power holds out. If it doesn't, I'm going to try and rejoin, but bear with me. Fingers crossed that the weather holds out and I don't lose power. All right. So, again, thank you all so much for the opportunity to talk. It's always a real thrill for me to talk about my personal favorite marine mammal, the North Pacific right whale. This is where I would normally ask people in the audience if it was a live talk,
All right, I think Jessica is dealing with a storm up in Seattle, so and I know she's been having some Wi-Fi issues. We can give her a minute to see if she can rejoin, and I think her she's gonna try to switch over to her hotspot versus her Wi-Fi. So please bear with us. Sorry about that.
Okay, I'm back. Can you guys hear me?
Yeah, you're good. Thank you for the quick IT support over there. You can do it all.
I don't know about that, but all right, we're back up and running. Hadn't even gotten a chance to start. Let's try this again. All right, well, no more intros. I'm just going to jump right into it now. So, for many of you, these first few slides might be a little bit of a review for those who do know about North Pacific right whales. But for those who don't, they are a large baleen whale. They can grow to be about 50 to 60 feet long. They are filter feeders and they eat zooplankton, predominantly copepods and euphausiids. There are three different species of right whales. You have the North Atlantic right whale, which is the most commonly known, that occur along the east coast of the US. The southern right whale, with various populations spanning the Southern Ocean. But obviously, the North Pacific is the one I'm going to be talking about tonight. The North Pacific right whale is separated into two populations. You have the western population that's found primarily in Japanese and Russian waters. And then you have the eastern population that is found in US and Canadian waters. And studies have shown that these two populations are genetically distinct. So even if there is spatial overlap between the populations, it doesn't appear as though they're interbreeding. And the Western population is thought to number in the low hundreds, maybe 300 to 500 animals. We don't really have an accurate abundance estimate for them. But it's the Eastern population in particular that I'm going to be focusing on for this talk. Right whales were once widely distributed throughout the entire North Pacific and Bering Sea before they became the target of commercial whaling. And it's estimated that between 26 and 37,000 animals were taken, with the majority of that occurring within just a couple of decades. And this brought the population down to what we think was probably the high hundreds. But then the Soviets began illegally whaling in the early 1960s. And in just a handful of years, they took over an additional 700 animals and just decimated what was left of the Eastern population. So then, to try and get an abundance estimate, NOAA began conducting surveys in the Bering Sea in the early 2000s. And from those data, they found a population size of only 30 animals. Of that, only 8 were females, with a 2-to-1 male biased ratio. But a recent study by Pastene et al. Found that the actual ratio is closer to 3-to-1, which unfortunately is the opposite ratio you want when you're trying to rebuild a population. And although these results are specific to the Bering Sea, the infrequent sightings outside of the area would suggest that the overall population size is likely fewer than 50 animals. So there are about as many people in this talk tonight as there are animals within the eastern population. So they are very much facing extinction. So because of this, NOAA designated 2 areas of critical habitat. All right.
There you go.
We good? Okay. Hopefully I didn't miss too much. Let me reshare
No, it
my
was
screen.
like 15 seconds max.
Thank you all for your patience with these technical difficulties here. So we know that they can be found in the Bering Sea and the Gulf of Alaska every summer. But what we don't know is where they go, when, or even if they leave the Bering Sea. Their migration routes and their calving grounds are completely unknown. Yeah, let me get back. There we go. So now we do suspect that they migrate south, just like most other large whale species do. And this is supported by the sightings data. We have had one high to low latitude match where an animal that was first seen in Hawaii in April of 1996 was then resighted later that year in the Bering Sea. And then more recently, we had an animal in British Columbia in June of 21 that was seen just a couple months later in the Gulf of Alaska. But so far, these are the only two instances of a long distance or a high-low latitude match of right whales. But if you do look at the recent sightings data by month, you can see that all of the sightings down off the coast of California, at least since 2006, have been occurring in those spring months, February through May. And so that does seem like it would lend itself well to being a migratory route. And we have had recent sightings occurring every year for the past 3 years, which is really exciting. So it does lend itself well to this migration hypothesis. But interestingly, in 40 years of photo ID data collection, we have never had a match of an individual from the Gulf of Alaska to the Bering Sea. And so because of this, we think maybe this population is comprised of two subgroups and that perhaps they kind of use different migratory corridors. But in this case, we have an N of 1. And so in any event, it's all hypothetical until we can get some more data. So you might be thinking, well, hey, put a satellite tag on them, see what the tag data show, right? So we tried this. It's been really successful for some other species. And so in 2004, and then again in 2008 and 9, we managed to get 5 tags out on whales. And while this did provide us with a lot of really great fine scale habitat use data, unfortunately, all the tags fell out before the animals left the Bering Sea, which left the question of their migration routes completely unanswered. So, why is it that we still know so little about these animals? Why are they so difficult to study? Well, to help answer that, I like to look at the Atlantic right whale for comparison. Now, for better or worse, their entire migratory route is along the coast of US and Canada. So at any given time of the year, you can head somewhere along the East Coast and see some right whales. And because of that accessibility, they are extremely well studied and well known. Ours, however, are not the least bit easy to access. So to start, the only place we know that they occur with any kind of regularity is the Bering Sea, which is a pretty massive area for only about 30 to 50 animals. Plus, it's about a full day steam to their high density area from the nearest port, Dutch Harbor. And the Bering Sea is grumpy at the best of times and downright awful at the worst of times. So imagine trying to find anything in these conditions. This is actual footage from a dedicated right whale survey that we were doing in the Bering Sea. And you can kind of start to see why we've had some difficulty in actually finding these animals. But I like to kind of break it down a little bit, even further, into what I call the right whales by the numbers. So I've been going to Alaska now every summer for 15 years, minus 1 year because of COVID. And that has amounted to 712 days. But to be fair, some of those were in the Chukchi or in areas where right whales don't occur. So if you limit those to areas of their historical distribution, it's about 579 days. Of that, we've seen right whales on only 24. And so for those who don't like math, that's only about 4.1%. So that's one of our really big struggles that we face is, we even went 5 years without a right whale sighting. And we've only been in the presence of right whales for about 74 hours or so over 15 years. So that's why we've really struggled to learn really anything about these animals is they are the proverbial needle in a very large and very unforgiving haystack. All right, so how do you study a population that only numbers in the tens of animals where you don't know migration routes, calving grounds, or even some basic life history questions? Luckily, right whales are highly vocal, and so they are an excellent candidate for passive acoustic monitoring. And so they make predominantly 3 call types. The first is called a gunshot, which you can see on the top. This is the predominant call type for this population. And I'm going to stop sharing temporarily just so that I can share it with the audio so you guys can hear it. It sounds exactly as you guys would imagine based on the name. And now I'm going to go ahead and share the screen again and play the other two call types back to back. So the first is an up call, and then I'll play the other tonal moans for you. All right. Hopefully we're back in action and you guys can see that screen again. So the up call is thought to be a communication call, a contact call between conspecifics, and then they'll make another variety of calls, moans, and tonal sounds. And there are a wide variety of acoustic platforms and equipment that you can use depending on your target species, what your research question is. Today, I'm going to be focusing on two different types, kind of a long-term autonomous hydrophone, as well as a sonobuoy or drifting buoy. So while we're out at sea trying to find right whales, we use an instrument called a sonobuoy. And this is an instrument that floats in the water and it will transmit sounds in real time back to a receiver on a vessel using VHF radio waves. And the great thing about these is that it's transmitting everything in real time, right? So if a whale starts calling, we hear it as it happens. But the other really great thing is that they have directional capabilities. So if we start hearing a right whale, we can deploy multiple sonobuoys at once. We can actually listen to as many as 3 sonobuoys simultaneously, and then we can localize or triangulate on their position. And from there, our plotting software over here will actually give us a position, a distance, and a bearing to the animal, which we can then give to the captain, and the boat will then head that way. Hopefully we'll find the animals and then can start to work them and collect photo ID data. And I think a really great example of how these have increased our right whale sightings is with the IWC sponsored power surveys. So I've been participating in these surveys since 2017 when they first started surveying the Bering Sea. And we included acoustics because they were going to be in right whale territory. So we wanted to increase the likelihood of finding right whales. And because of this survey, since that first time I joined, we've actually been able to find and photograph 17 unique right whales. We have added new animals to the catalog. We've been able to recite individuals. We've even been able to get biopsy samples from 6 individuals, all of whom were of a previously unknown sex. So really incredible results. And with the addition of sonobuoys, on average, about 2/3 of right whale sightings during a survey are a result of acoustic localization. But the real bread and butter of the work that we do here is using our long-term passive acoustic recorders. So we have been deploying these year-long bottom-mounted recorders at about 25 sites, some of them going back as far as 2007. And these are deployed all throughout Alaska. And they record to an internal hard drive. And so you actually have to retrieve the instrument in order to get the data, but they're able to record for a full year. So we'll deploy them, come back the next year, retrieve them, put new ones out. And then just by listening to what species are calling, we can actually determine presence of marine mammal species. Because we have so many located throughout all of Alaska, we can track their migration and movement patterns, whether that's changing as a result of climate change. But the best part about these is that they can monitor year round for marine mammals when vessel or aerial surveys aren't possible because of the ice. So I want to go through some of these results here. Oh, goodness. All right, I'm back. Again, thank you very much, everyone, for your patience. Much appreciated. All right, I think I'm sharing again. So yeah, so what you're looking at, black bars are right whale calling activity. The blue bars are your percent ice concentration. And then the horizontal black bars is recording effort. And so this is one site over 2 years. Now we can actually zoom out and look at 7 sites over 7 years. And now these are color coded based on the locations on the left and arranged latitudinally for ease of viewing. And so this is a really nice example of a long-term time series of acoustic detections for right whales throughout the Bering Sea. And so right away, you can see we've got consistent annual summer fall presence of right whales at these southern sites, often continuing into winter. But interestingly, when you look at a year that had a very strong cold bottom temperatures, you can see that right whales are really concentrated down into their critical habitat. But when you look at years that had really warm bottom temperatures, they're actually much more widely distributed throughout the entire shelf. And we'll get back to this in a bit, so keep that in mind. But like anything with our whales, of course, there are complications. So a colleague of ours sent us a clip of a gunshot, and we said, yeah, that's a right whale. What of it? And she said, nope, that was a bowhead whale that was recorded off Utqiagvik. So not only do bowheads produce gunshots and upcalls, but they can be impossible to distinguish from right whales. So here you're looking at about 4 minutes or so of calls from a Bering Sea mooring that was over winter, 100% ice cover. Most of what you're looking at here are bowhead whale song, but right in the middle of it, we have 3 textbook right whale upcalls. And we don't know if these are right whales or bowheads. They overlap. So that's one of the problems that we've been looking at. So if you look at our data again, but now anywhere you have gray shading is where we have bowhead whale presence. And now the plot is showing any detections that look and sound like right whales, but that are under 100% ice cover with bowheads present. So for right now, all of these are just considered kind of ambiguous or maybe calls and aren't used in strict analyses just because we don't know which species made the call. But one way we are hoping to distinguish them is through song. So while we were analyzing our data, we started noticing these kind of repeating stanzas of the gun like humpback whales. All right. Well, I was able to join a little faster that time. But these songs are comprised almost entirely of gunshots. And so far, we've found 4 different song types that have remained stable over at least 8 to 10 years. And this hasn't been found yet in any other right whale population. And so far, bowheads haven't been found to produce song using gunshots. So right now, this appears to be unique to our little population, which I think is fascinating and actually ends up kind of raising more questions than it answers. Some of the other work that we're doing is looking at stable isotopes in baleen plates. And this is work that my colleague Dana Wright is doing. We're trying to see if we can uncover calving grounds or migration routes using stable isotopes in baleen plates. So for those who aren't familiar, stable isotopes are kind of like a chemical tracer of your diet that gets encoded into the baleen of the whale. And you can analyze them to get, an isotopic ratio or a delta N value that corresponds to your prey. So a good way to think of this is, for example, I like pizza. I love eating pizza. So when I eat it here in Seattle, all of those ingredients will leave a chemical tracer in my body that kind of corresponds to, let's say, 14 on the scale here. But if I go to Italy and eat pizza there, it's the same food, right? It's still pizza, but that chemical tracer is going to be a little bit different because of the source of the ingredient. You could infer that I have been traveling back and forth between Italy and Seattle. And so for baleen, you can compare the values in the baleen to known isotopic values in other regions to try and kind of back calculate where the animal was when it was eating its prey. Woo, too far. And so looking at this, all of the, oh my gosh, now my computer's freaking out. There we go. So all of the values in the kind of 12 to 15 range correspond to the Gulf of Alaska, but any values in that 7 to 10 range correspond to that eastern North Pacific. And so it looks like this animal was making regular migratory transitions between the two areas. And so Dana's now trying to look at other baleen well plates to see what kind of data those find and whether there might be any trends emerging from these other baleen well plates. Really exciting stuff. So stay tuned for that. So we're also looking at modeling zooplankton prey. And many studies have found that in years with colder bottom temperatures, copepods are abundant down in the right whale critical habitat. But in years where you have warmer bottom temperatures, those copepods are actually shifting north, and that corresponds really well to retreating sea ice. And so Dana's finding that, we're seeing this shift in right whales and their distribution to the north as they're following their copepod prey. But she's also going to be looking at doing a joint species distribution model where she's now going to be incorporating data from foraging fish species that eat the same prey, but that there are much more data available on. And so she's hoping to then determine what other areas right whales may be concentrated in that are outside the detection range of our recorders so that we can increase our knowledge of their distribution throughout the entire Bering and Gulf of Alaska and not just those positions where our recorders are located. Another aspect of our work is we're trying very desperately to get an updated population abundance estimate. So that number 30 that I mentioned at the beginning is not only limited to kind of the Bering Sea region, but it is now 14 years old. So we're hoping to use our photo ID data in a mark recapture analysis to try and get at an updated abundance estimate. And we have enough resites. We should be able to do this. And excitingly, we should have enough for the Gulf of Alaska region as well to be able to get an abundance for that region and hopefully have a better idea of the total population size. And hopefully that is coming this spring. Now, this animal is not just an Alaska species, right? And so we're also trying to increase our monitoring outside of Alaska, increase our international collaborations. So we've been working with colleagues at DFO Canada to analyze some of their moorings off the coast of British Columbia. And we've actually been able to successfully detect right whale upcalls at those sites that you see in yellow. And it looks like the timing of those do correspond to what would be the migratory period, but we're still kind of analyzing those data to look for trends. And we're also kind of excited about the possibility of satellite imagery. So this has been really successful so far, or proven useful for Atlantic and southern right whales. But in areas where they're coastal, they know where to look. For North Pacific right whales, it's still very much in the R&D phase. Not only is satellite coverage in the Bering spotty, but it's often covered in clouds and renders any satellite images useless. But what we are really excited about is the possibility of using satellite imagery to perhaps confirm those sightings that you see here in blue that don't have associated photos with it, where we might be able to confirm species or the number of animals. So we get a lot of reports from people that said, hey, I saw a right whale, here's where, but I couldn't get any photos. Well, we might be able to go back into the satellite data and actually confirm the species and the number of animals. But then hopefully someday we're excited about the possibility that it might advance enough to the point where we can then use satellite imagery to kind of help us survey in areas where we can't easily get to, but where right whales were once historically distributed. All right, so that was a lot of science. How do you kind of turn it into management? So in March of 2022, NOAA received a petition from the Center for Biological Diversity and Save the North Pacific Right Whale to expand the right whale critical habitat. So right now, these red polygons are what the current habitats look like. Well, this petition has requested that we expand it out to the west, south to the Aleutians, and then connect it all the way over to Kodiak Island. And NOAA did find, after reviewing the petition, after reviewing the data, that the habitat does warrant revision. So to clarify, they have not indicated how or where they will revise or expand it to. It may or may not include some of the areas in the petition, but that is the next step in the process. And so our role as scientists is to provide the science and the data to those policymakers to help in their decision. So we're going to be collating everything that we know about these animals. Again, this is a location of all of our currently deployed recorders that are in or near right whale territory. So we're analyzing all of these data in conjunction with recent sightings data, oceanography, zooplankton, to try and get kind of one holistic approach at where right whales are and what areas could be considered critical habitat. And then we'll give those data to the regional office and they will make that final determination of how and where to expand the habitat. But another aspect of management is why these animals haven't recovered. And unfortunately, that's the million-dollar question. We don't know. If I did, I could probably retire early. But that's the unfortunate thing is we really aren't sure why. Other populations and other species have recovered from similarly low numbers. These whales have been protected since the 70s. Here we go again. So yeah, these animals, they've been protected since the 70s, but we have no evidence that they are in fact recovering. So some factors, since 2004, only 4 known females have been sighted. And granted, there are a lot of sightings for which we don't know the sex of the animal, but remember that there were only an estimated 8 females to begin with. And we don't know how many of them are still reproducing. And although we were able to collect 6 new biopsy samples, all from animals of previously unknown sex, 5 of them ended up being a male and only 1 female. We also haven't seen a calf in over 2 decades. And even the old whaling logbooks, if you go back through them, say that there was no evidence of calving grounds anywhere in the North Pacific. And yet, despite that, we have had several sightings of non-adults. We had a subadult in Gulf of Alaska, 2005, another one in British Columbia, 2013, and most recently, we actually had a juvenile seen in the Bering Sea. Now, these animals were all calves at one point, so that really kind of begs the question, where are the cow-calf pairs? Is it that we are not surveying in the right areas? Are they just so rare that we're missing them? But if we could figure out even this one key piece of information, that would go a long way toward our recovery and our management efforts. There are also a lot of threats this population faces that could be hindering their recovery. So one of the biggest ones is entanglement. Alaska has one of the largest fishing industries in the country by volume, with several pot fisheries for many species. And although there are only 2 animals in our catalog that have entanglement scars, the rarity of sightings combined with the extremely remote location means it's really unlikely that any animal that does get entangled would be sighted and reported before it dies. So while this is certainly, this is a huge possible threat, there's a lot of overlap between them, but we've been struggling to quantify the direct impacts of entanglement on the population. But that said, it is pretty regularly documented for the Western right whales, as well as for bowheads. And you heard earlier that bowheads will come all the way down into right whale territory. So this is a problem for other species, other populations that share similar territories. But again, we've really been struggling to quantify those impacts. Another big threat is interactions with vessels, right? Ship strikes, either from commercial shipping or potentially fisheries from all the fishing activities. So this map is a density plot showing all of the traffic from 2023. And the Great Circle shipping route for commercial shipping from North America to Asia runs right through Unimak Pass. And that's where we have an acoustic recorder, but we think it's one of the main passes that right whales are using as they're transiting in between the Bering Sea and the Gulf of Alaska. In this plot here, all of that orange represents vessel noise that we've detected on our recorders. With that bottom row, Unimak Pass, that's the one that we think right whales are using. And so it paints a pretty staggering picture about just the amount of overlap between right whales and vessels. But again, we haven't been able to quantify it. We have no animals in our catalog that have vessel strikes. But is it because they're not getting struck? Or is it because they're getting struck and they're dying before anyone can see it? So one thing I'm asked often is, how is climate? One thing I'm asked often is, how is climate change impacting this population? And we're still trying to fully understand the impacts of a warming Arctic on this population, but there are some evident trends. So this plot on the left shows the average temperature change across the world in the last 14 years relative to the baseline from about 60 years ago. And I think it just really highlights how badly the Arctic is being impacted. And the right-hand plot shows the change in sea ice cover relative to the average, or that dotted line is the baseline. And so you can really see the larger fluctuations that we're having and that huge extensive warming period that we had for several years in a row. So how does this impact right whales? Well, a lot of studies have shown that decreased sea ice and warmer bottom temperatures result in smaller and less lipid-rich zooplankton. And so this plot here on the right, it shows the average abundances of various zooplankton classes. But I want to draw your attention to that middle row. So these are the large copepods that right whales primarily prey on. And now here I've highlighted where we've had warm or cold stanzas. And you can see that the colder temperatures really favor those large copepods, but warmer temperatures result in fewer copepods. It tends to be more small copepods. And so if you go back again to our acoustic data and look at this through that lens again, here are those blue stanzas where we've had cooler temperatures and we've had greater concentrations of right whales down in their habitat. But then in the warm years, we're seeing right whales farther north. And so as the climate warms, it's very likely that we'll end up seeing a distribution of right whales farther north as well as they follow their zooplanktonic prey. There are a few other threats that we are trying to understand better. The first is predation. So this photo shows right whale flukes with very clear killer whale rake marks on the fluke tips. And while we don't know what kind of impacts killer whales may be having on right whales, they have been increasing their predation on bowhead whales. And since the loss of just a single animal in this population would be devastating. So this could pose a very real threat to a population that's trying to recover, but it's just still very poorly understood at this point. Harmful algal blooms recently have been getting some attention. A few years back, we had 30 southern right whales that beached off Argentina, and the cause of death was actually linked back to harmful algal blooms. And unfortunately, it was the females that were impacted most heavily because of the increased foraging due to the energetic demands of nursing and calving. But these harmful algal blooms are becoming more prevalent in the Bering and Arctic as temperatures continue to increase. And we've even started to see impacts to walrus and even bowhead whales. So this is something that definitely needs to be on our radar moving forward. And finally, there's other threats like marine debris. Everything in this photo was actually pulled from the stomach of a southern right whale. And then you have microplastics, which are not as well known for this population, but also noise, which would pose a real issue for communicating with conspecifics when they're already so few and far in between. So now I know this talk hasn't had a whole lot of positive aspects to it. It's really difficult to inject joy into a talk when about a population that's facing extinction. But I do want to say very much that there is still hope. All the animals that we see are what I like to call fat, dumb, and happy, but what my PR department prefers that I say robust and healthy. They all have very clean skin with few parasites. They have very few scars. But more importantly, we continue to see new animals. We continue to recite individuals. We've even found a juvenile, so there is still some reproduction happening. So even though the odds are stacked against them, these guys are few, but they are very resilient and they do still stand a chance at recovery if we can just help them, give them their best chance. Now, I'd be completely remiss if I didn't talk about how to identify a right whale for those who don't know. So as I'm sure by now you know or have seen, they are they're big, they're dark, they've got a wide flat back with no dorsal fin. They have callosities on their head, these white patches, and that's what we use to identify individuals. The pattern of those is unique to each right whale, kind of like a fingerprint or a humpback fluke. And fun fact, those patches are white or sometimes orange in color. Oops, because they're covered in cyanids or whale lice. So it's a fun little fact for you. Now, when surfacing, if you're lucky enough to not have a strong breeze, you will see a really nice, distinctive V-shaped blow. Their flukes are really wide, clean edges are triangular with a deep notch in between. And then finally, their pectoral fins have this really kind of unique paddle shape. So if you're seeing any one of these, you should automatically start thinking a right whale. But I do also like to show photos of right whales alongside other species that they are often confused with, so you can kind of really see nicely how they differ. So this shows obviously comparison of a right whale with a humpback in the middle and a gray whale on the right. Um, and I also like to include this because right whales are very frequently found associating with other species. In the middle of an aggregation of 50 humpbacks, you'll find a right whale or two. So I think it's always really nice to kind of show those differences side by side so you can really see them. So what can you do? I'm asked this also a fair bit. The biggest thing that you can do and the biggest help for us, honestly, is to spread the word about these animals and most importantly, to familiarize yourself with them. As you've heard, sightings on the West Coast have been increasing, right? They've had one each year for the past 3 years. So these guys are starting to show up in your backyard with more and more frequency. And the more people know about them, you know, anyone who's out on the water could be eyes for us. And so it's really important that we know to look for them and we know how to recognize them. So please keep a weather eye out on the horizon for that nice V-shaped blow. And I'm just going to wrap it up by mentioning what to do if you are lucky enough to see a right whale. So obviously follow the regulations, right? Slow down, keep your distance. If you're able to get photos or videos, even distant grainy ones, please do so. Please share them and let us know. Please report it. We have a right whale sighting email that should be hopefully easy to remember, np.rw@noaa.gov. You can email me, shoot me a text. We really appreciate these photos. Our opportunistic reports have been increasing in recent years, which is really encouraging. And we would much rather have a whole bunch of false alarms rather than risk missing that one right whale. So please do report it if you're in any way unsure. And with that, The saying is very much true. It takes a village. Mine is large and spectacular, and it would certainly not be possible without a whole lot of people that I have to thank. But I'm actually going to leave it on this last slide here, at least for a while, and take questions. Thank you all so very much. And thanks again for your patience with the weather difficulties.
Awesome. Thank you so much for that. And I think we need to start incorporating more dramatic pauses because you had some good cliffhangers there. I think everyone was on the edge of their seats wondering what the climate change impacts were. Um, but great. So we have a few questions coming in, and if anybody has more, please continue to drop them in the Q&A. I'll try to kind of organize these as I go. It looks like we have a few about reproduction. So one is it known whether Pacific and Atlantic right whales were able like are they physically able to mate or reproduce
Uh, I assume you
with
mean
one
like between
another, I
the two
assume.
species. So if an
Yeah, yeah,
Atlantic
yeah.
whale made its way
Yeah,
over,
are
uh,
they separate species or are they
right.
yeah.
So they are separate species. They are genetically distinct. That said, I mean, I imagine biologically speaking, they are similar enough that it would be possible, certainly. I just wonder if they would, only because we have the Western population that is also a North Pacific right whale that they're not interbreeding with. So I think it's certainly biologically possible. I just don't know if it would happen even if they were in the same location.
Makes sense. And then as far as just kind of given how small of a population it is and for how long that's been the case, have you seen or hypothesized of any implications due to kind of, inbreeding on the new generation?
So that's a great question. The same genetic study that found the new updated male ratio, they actually found a surprising amount of genetic diversity still remaining within our population. They aren't as genetically diverse as the Western population, but they are quite a bit more genetically diverse than what you would see for the Atlantic. So surprisingly, yeah, that doesn't appear to be an issue yet.
Awesome, thank you.
Mhm.
And then as far as I guess their habitat, do they prefer deep water or coastal shelf or both? Are they seen everywhere?
In recent years, they've primarily been seen coastally in shallow waters. But historically, there were takes all throughout the deep basin in deep waters. In 2012, a right whale was seen in waters that were, a couple kilometers deep. But most recently, they've all been pretty coastal, within, maybe a couple hundred meters depth or so.
Awesome. Makes sense. And then on the slide that you were kind of talking about I guess how were you able to get a hold of the baleen plates for the isotopic analysis? Was that from dead whales or is there a method of getting them live?
Yeah, those are all historical samples. So those were either whales that wash up on shore or whales that were taken back during the catch times. So all of the plates obviously are from the 1960s or older. We haven't had any contemporary plates from whales.
Awesome. And is there I guess one more, is there anything I guess technologically that you're most excited about in the future, whether it's, advanced satellite imaging that can help out or, the buoy systems that continue to get better and better every year. What excites you in your field most?
Yeah, there's a lot of really amazing emerging technology. Satellites, I think we're still a ways away for them to be really useful just because of the spotty coverage in our region. Um, I think what they're able to do with drones these days is really amazing. They're able to drop acoustic detag basically on whales using a drone. And so to be able to kind of get that movement, habitat use data with the acoustic data, all from a drone where you're minimizing your close approaches to the whale, the stress to the animal. I think that is really, really exciting. These animals, you're dealing with the survivors of a population that was wiped out by whaling. And so these are the ones that swam away. So as soon as we get any vessels near these guys, they stop calling, they swim away, their surfacing patterns become completely erratic, and then they disappear. It's amazing to me how a 60-foot animal can vanish with 10 of some of the best observers looking for them with big eyes. They're really, really good at it. And so if we can, launch a drone and get some of those data before we even get the large vessels near them, I think that would really increase the data collection that we're able to get while minimizing stress to the animals.
That's awesome. That's really exciting. And sorry, we just had two more come in at the buzzer. So if you have a sec, we can go over
Oh
these
yeah.
real fast.
Yeah,
Um,
absolutely.
cool. Well, so one, do they have a similar or a totally different dialect to their counterparts off the East Coast?
Another great question. So all right whale populations will make gunshots, up calls, the other kind of tonal calls. The other populations have a larger known repertoire because they have a lot more kind of concurrent visual and acoustic data. So they know that right whales are making those specific calls. The difference is our gunshots sound a little bit different, which could be a result of the propagation differences from the different environments. It could be something the whale is doing. We haven't had calves in 20 years, so we have no recordings of cow calf pairs for our population. But also our population, the frequency of call type of usage for each call type is different. So our population almost exclusively gunshots. 75% of the time it's gunshots. The rest of the time is up calls. Whereas for the other populations, those ratios are much different.
Awesome, makes sense. And then the last one for real this time. Have you seen any unique social or individual behaviors? I assume referring to right whales generally, versus, individual specimens.
Yeah. So for right whales generally, well, my first encounter with a southern right whale was when they were sailing. They were just hanging head down with their flukes up in the water, just chilling with the flukes out. And I thought that was just bizarre. As far as our population, we haven't really seen a whole lot of crazy behavior because again, our guys tend to stop most of their behaviors when we get near. But in 2009, one of our females named Smudgy was caught playing with a log, rolling it over her back, playing with it, shoving it underwater. And so that was really neat to see, a big whale playing with a log and just having a grand old time with it.
Oh, that's awesome. Um, well, cool. Thank you so much for taking the time again. And I know you had some
Yeah.
acknowledgments to go through. I think I get there is one more question about are there any papers that folks could reference if they want to learn more or books or any publications?
Yeah, there are quite a few publications out. Not so much about physical behaviors, but we've got some acoustic manuscripts that are out. You can Google my name or Dana Wright's name. There are quite a few for the Atlantic right whales. It's a much better studied population. But yeah, there's a few of them out there. You can also go to the NOAA right whale website. That's got some really nice info in there and some links to stories and publications. Yeah.
Awesome. Well, thank you so much. And yeah, for everyone else on the call and obviously you're invited to Jess, have a fantastic holiday season and please join us for our next speaker series, which will be the 28th of January.
Great. Thank you so much, everyone. Thanks for taking your time tonight. Always a pleasure.
Well, stay dry up there in Seattle, and I guess same to everyone in the Bay Area.
Yep.
Have a
Sounds
good
great.
have a good one.